My name is Joseph Smar. I'm a software engineer at Google. I currently work on Google Photos.
My name is Christopher Lamb, and I work at NVIDIA. I run a team that builds software for GPU and cloud computing.
I got involved working on these Dreamscape project almost by accident. Dan Ambrosi, the artist, is an old friend. We worked together at my last startup, Plaxo, and we ran into each other one afternoon, and he told me he'd had this great idea to use the DeepDream software that Google had recently released in conjunction with these large landscape photos he'd been doing. It had never occurred to me to mash the two up together before, but he'd actually tried it out on some small versions of the images and had some pretty intriguing results, and so it seemed like an interesting opportunity.
My good friend Joseph Smar contacted me, and he told me he had a problem he wanted to solve for an artist friend of his. His friend Dan Ambrosi wanted to apply the software called DeepDream to images bigger than anyone had ever applied it to before, and he was running into some technical challenges, and he wondered if I was interested in helping him solve them. He thought I might be interested because DeepDream uses GPUs to do its computation, and so he thought that a side project on something that touches on what I do for my day job would be kind of an interesting thing to undertake.
Once we cracked open the DeepDream code and started looking at how it worked, a number of problems became apparent. The first is that the neural network that has been trained to recognize images, which is what's used to produce the hallucinations, is designed to work on very small images. And normally the images are just scaled down to only a few hundred pixels on a side before they're fed through the network. So obviously that wouldn't work if we wanted to then blow it back up and get the level of detail that the original image had. Worse, the GPUs, the cards that the images actually run on to do the dreaming when you actually run the network, they only have a fixed amount of memory, and there's no way you could take the full-size image and run it through the graphics card at the same time. So it became clear pretty early on that we were going to have to chop the image down into lots of little tiles, dream on the individual tiles, and then somehow stitch them back together. But exactly how to do that was a little bit tricky, especially because we didn't want to see any seams, where we'd done the stitching. So the first thing we did was we figured out a way to step through different subtiles of the image and dream on each tile. And one of the tricks we got from the people inside of Google was by sort of randomly jittering the exact placement of the tile each time and going over the whole image multiple times, the whole thing sort of ends up blending together in a smooth way where you really can't tell where the tiles were. We also sort of take the image and size it down and back up multiple times and do that at each scale. So you start to get sort of multi-scale features in the image, and also that again helps make the whole image look a little bit more harmonious.
We sort of found little hiccups and speed bumps at just about every stage through developing the software. And we quickly realized that to try and replicate the kind of machine that we needed to run the software efficiently, it was going to cost Dan tens of thousands of dollars. And we had already stood up an instance in Amazon Web Services, and we thought to ourselves, well, this is probably the better way to do it, is actually stand up the services in the cloud. And we even thought that should we run out of resources with one instance, there was a possibility of potentially scaling up to more machines, things like that. It was really going to be able to adapt to the capacity of Dan's workload. As much work as he wanted to throw at the technology, we were going to be able to create something that could handle it.
The next step was, how do we actually unlock Dan's potential as an artist to do something interesting with this? And there were sort of two challenges there. The first challenge is there are a zillion different parameters and settings you can tweak with exactly how you dream on an image. And of course, for artistic effect, you might want to do different things with different images. And we really didn't know what the sweet spot would be. Dan had some initial sort of promising results, but it was clear that some more exploration was needed. And so we realized we would have to build some sort of a web interface or some sort of a UI in front of the core dreaming engine that would allow him to upload an image, set some parameters, try it out, save his results, and so forth. And then the second piece was just to be able to package it up in such a way that, on his own, Dan could start one of these servers up and get everything running and do his work and then shut it back down, because we were still doing a lot of the heavy lifting and hand-holding to unlock Dan. And again, we sort of figured this should be possible, but it wasn't something we had any prior experience with. And so we just sort of dove in and built it piece by piece. And after a while, we got something that worked pretty well. What was funny once we got the DeepDreams working at scale with Dan's images is, of course, you've got this multi-hundred megapixel image, but your computer screen is only a few megapixels, right? And so we never actually got to see the full thing at full size, which is, of course, the whole point of the project, to give you that sort of visceral sense of looking at a giant landscape. And so once we got it working, and once we saw how compelling the images were by panning and zooming, our next mission became finding some way to free them from their digital prison and actually get to see them in the real world at scale.
I had been looking at these images, sort of working on the software quite a lot, and I thought, gosh, wouldn't this be great to see at the full size? Dan had told me about, the impact these can have when you have them blown up to, 8 feet by 16 feet. And I thought to myself, gosh, wouldn't it be great to have them shown at the GPU Technology Conference that NVIDIA puts on each year? And that seemed like a good forum to me, because NVIDIA really is about this confluence of artistic enablement and high performance computation. So it seemed like it hit all the marks. And sure enough, they were really, really interested in that. So we didn't have a lot of time to pull it off. It was about 6 weeks to conference, so it was incredibly last minute, but I was really excited that everything worked out, and we were actually able to get 3 of those works full size at GPU Technology Conference.
It was really the first time that we could see them at that level of detail, at that scale, in the real world. The backlighting looks fantastic. The resolution, you can walk right up to it and see the details. And they became this sort of surprise hit of the conference, where people would pull their friends to come see it. They were taking selfies in front of it. They were asking questions about it. And it just, became almost kind of a cultural touchstone for the conference. So it was really awesome to see.
I found this project really interesting to work on because it really exemplified what I'm trying to achieve in my professional life, which is getting incredibly transformational computational tools in the hands of people who can use them in unexpected ways. There are always lots of challenges in doing that well, and this was an amazing opportunity to learn, from end to end what it takes to overcome those challenges, make a difference to an artist, and also hopefully improve the rate and the ease with which we can get these kinds of tools into people's hands to do incredible things, whether that's art or science or medicine.
It's really surprised me not only how well the work has been received, but it's been meaningful to me in a way that I didn't expect, to have helped empower an artistic voice to especially talk about the collaboration between man and machine that is on all of our minds these days as AIs become more and more powerful. And to do it in such a sort of beautiful but still profound way. I mean, this is just something that I guess it made me realize that I've spent most of my career as an engineer thinking primarily about utility. How can I make useful tools? And that using some of those same skills to unlock creativity and to help sort of people think about what they want to express and not just what they want to get done is something I'm definitely going to try to look to do more of in the future, because it was a meaningful experience for me.